Hi everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. If you are new to the channel, please subscribe the channel so that you will be updated for the upcoming lectures. In the previous video, we have seen how a simplex algorithm works, and we have also seen that in order to solve a problem through simplex method, we need to convert the general linear programming form into a standard form. So if you have not watched the previous video, I request you to please go and watch the previous video so that you will have a clear understanding of how to approach a simplex method problem. And in order to make your concept more robust, today I bring to you a very beautiful question. So let us begin with the question. So this is our question: maximize z is equals to 4x1 plus 3x2 plus 6x3 subject to constraints 2x1 plus 3x2 plus 2x3 less than equal to 440, 4x1 plus 3x3 less than equal to 470, 2x1 plus 5x2 less than equal to 430, and x1, x2, x3 greater than equal to 0. Now we need to convert this form into standard form, and before doing that we need to ensure that the right hand side value of the constraints has to be non-negative. So we can see that in all the three constraints the right hand side value are non-negative. So now we can move ahead and convert these inequalities into equations. Now as we can see that this first constraint 2x1 plus 3x2 plus 2x3 is less than equal to 440. This means that this equation, left hand side of the equation, is either equal to 440 or less than 440. So let me write here: maximize z is equals to 4x1 plus 3x2 plus 6x3, okay, subject to constraint 2x1 plus 3x2 plus 2x3. So this value has to be either less than equal to 440 or less than 440 or equal to 440. So what we need to do here, we need to add a slack variable s1 so that this will become equal to 440. What this means is that if this term 2x1 plus 3x2 plus 2x3 will be equal to 440, then s1 will take value 0. That means s1 will become 0, and if this value will be less than 440, then s1 will have some positive value. So here we are defining that s1 can be 0 or positive. That means s1 is also a non-negative in nature. And similarly for the next constraint, we can see that 4x1 plus 3x3, or I can write this as 4x1 plus 0x2, as x2 is not mentioned, so I have written the coefficient of x2 as 0, plus 3x3 plus s2 is equals to 470. Similarly for the third constraint, x1 and x2 are there, so I'll write 2x1 plus 5x2 plus 0x3, okay, because x3 coefficient of x3 is not given, so I have taken is as 0, plus s3 equals to 430. And now the non-negativity restrictions: x1 comma x2 comma x3 comma s1 comma s2 and comma s3 greater than equal to 0. So now we have converted our problem into standard form, and before start solving in the matrix, we need to understand one thing, that slack variables or surplus variables, whichever it is a basic part of a problem, so that we must ensure that we treat the surplus or slack variable as we treat the decision variables. We'll see what it literally means, okay. So let us start solving first. Now To find the initial basic feasible solution, what we need to do here is we'll put the value of x1, x2 and x3 as 0, and I must write here the contribution of s1, s2 and s3 here is 0 s1 plus 0 s2 plus 0 s3. And why is it so? So that it will not affect our objective function, so their coefficient has become 0. Okay. Now to find the initial basic feasible solution, we need to find the variables which enter the basis column, and to enter the basis column the values has to be positive, some positive value. So if I put x1, x2 and x3 as 0, that means x1 equal to 0. If I put x1 equal to 0, x2 equal to 0 and x3 equal to 0, what I'll see is in the first equation I will get s1 is equals to 440. That means s1 is coming as positive, so it is the probable candidate to enter the basis column. Similarly, in equation 2 I can see that s2 will come as 470. If I put x1 equal to 0, x2 equal to 0, x3 equal to 0, s2 will become 470. So s2 can also enter the basis column. And similarly with third constraint, if x1, x2, x3 are 0, s3 will become 430. So we have seen that s1, s2 and s3 find their place in the basis column. Now here we write the objective function coefficient for x1, x2, x3. Okay, let me write them apart so that it will be clear. Okay, x1, x2, x3, s1, s2, s3. Okay, and their objective function coefficients are 4, 3, 6, 4, 3, 6, 0, 0, 0. And here also we are writing the objective function coefficient as 0, 0 and 0. Now here we will put the equations directly, coefficient of constraint equation, that is 2, 3, 2, 1, 0, 0, and the right hand side value is 440. Similarly for second one it is 4, 0, 3, 0, 1, 0, and this is equals to 470. And the third one is 2, 5, 0, 0, 0, 1, this is equals to 430. So this is our first matrix, and after that we will calculate Zj and then Cj minus Zj. So here I am directly calculating the values of Cj minus Zj because there is less space in the board, and calculating Zj or not calculating Zj separately will not affect our problem. So I will be calculating Cj minus Zj directly, and this is also known as the net evaluation row. So Cj minus Zj row, this row is also known as net evaluation row. So this will be Cj is 4, Zj is summation of x into aij, that means 0 into 2 0 plus 0 into 4 0 plus 0 into 2 0. So this will be 0, 4 minus 0 is 4, Similarly 3 minus 0 is 3. Similarly 6 minus 0 is 6. This will be 0 minus 0, 0 minus 0, 0 minus 0, and ultimately the value of z is also become as 0. This value is showing the value of z. So here in the previous lecture also we have seen that the variables in the basis column, okay, the variables in the basis column will have the Cj minus Zj value as 0. So here we can see that S1, S2 and S3 initially are in the basis column and are called basic variables. So their Cj minus Zj values are automatically 0, 0 and 0. So whenever we are solving a problem, if we can see that the variables in the basis column, we need not to calculate the Cj minus Zj value, because they will automatically come as 0. Now here, this is the first matrix, which is called the initial basic feasible solution, and now what we will do is we will select the maximum value in the Cj minus Zj row. So maximum value is 6. So we will select 6 as our key column. 6 will be our key column, and key column indicates that which variable will enter the basis column. So as we can see here that this is variable x3, that means variable x3 will enter the basis column and replace either s1 or s2 or s3. And now to find out the exit or leaving variable, we will calculate another term called theta, and theta is nothing but the ratio of right hand side value divided by corresponding key column element. That means the right hand side value of first constraint is this 440 divided by corresponding value in the key column. So as we can see here, its corresponding value in key column is 2. So 440 divided by 2 is 220. 440 by 2 is 220. 220. Similarly for 470, this will be 470 by 3. 470 by 3, and this is 430 divided by 0. Anything divided by 0 will be infinity, or I can simply put a dash, because we do not calculate we do not select the value of infinity. So I have just put dash here. We also need to understand that if we have any negative value, or I can say that if the value of theta is coming as negative, then we will not write the value. Instead we will put a dash sign just like this to avoid the variable from leaving. Okay, we'll see that in the other problems also how it works. Till now we need to understand that we've calculated theta, which is equal to right hand side value divided by corresponding key column element. So now at the intersection of these, here we will select the minimum positive value. As we can see here that 220 and 470 by 3. So the minimum value here among these two is 470 by 3. So this will be our pivot row. We have already understand what pivot row is in the previous lecture. So what pivot row shows that which variable will leave the basis column. So now we can be sure that variable x3 will replace variable s2. So now in the new matrix we have the value of s1 and then the value of x3 and the value of s3. Okay, and their objective function coefficient are 0, x3 is 6 and s3 is 0. Clear? Now Now the intersection of key column and pivot row is termed as pivot element. So this element is called pivot element, and what we need to do here is to make this element as 1 and the remaining element in this column as 0. Okay, what we need to do, we need to make this pivot element as 1 and the remaining values in this column as 0. So to make that, we will do some row operations. Here what I'll do is I'll divide the row 2, older row 2 divided by 3. So this will become 4 by 3, 4 by 3. This will be 0 by 3 is 0. This will be 3 by 3 is 1. This will be 0 by 3 is 0. This will be 1 by 3. This will be 0. This will be 470 by 3. Now I need to make the remaining values as 0. So I can see that this value is already been 0, so I do not need to do any row operations on this, and I'll write this third line or third equation in the matrix as it is. This will be 2, 5, 0, 0, 0, 1 and 430. Now I need to make this element as 0. What I'll do is the older row 1, this is row 1 of older matrix, so this will be older row 1 minus of 2 times of new row 2. Okay, R1 old minus of 2 times, because I need to make this as 0, this minus 2 times of this row minus 2 times of R2 new. So this I am going to do here. So this will be 2 minus 2 times of 4 by 3, that means 2 minus 8 by 3, and it will come as minus 2 by 3. Okay, this will be 3 minus 2 times of 0 is 3. Similarly 2 minus 2 times of 1 is 0. 1 minus 2 times of 0 is 1. 0 minus 2 times of 1 by 3 is minus 2 by 3. 0 minus 2 times of 0 is 0. 440 minus 2 times of 470 by 3. This will become as 380 by 3. This will become as 380 by 3. So this is our new matrix, and in for this new matrix we need to calculate again the value of Cj minus Zj. Cj minus Zj. So let us calculate this value. Now this will be Cj is 4 minus of 0 minus 2 by 0 into minus 2 by 3, 6 into 4 by 3, that means 6 into 2 8. This will be 4 minus 8 is minus 4. This will be 3. As we have discussed earlier, that the variables in the basis column will have the value of Cj minus Zj as 0. So I will be putting the value of S1, X3 and S3 as 0. That means S1 is here 0, X3 is here 0, and then S3 is here 0. So we need not to calculate these three values as they are in the basis column, and they will ultimately have Cj minus Zj values as 0. Okay, now let us calculate the remaining values. This will be 3 minus of 0 into 3, 0 is 3 minus 0 is 3 plus 3, and this is 6 by 3 is 2, 0 minus of 2 is minus 2. Okay, and here we will calculate the value of z. So this will be 0, this will be 0, 470 into 2, this will be 940. Okay, now as we can see here that in the Cj minus Z0 there is still one positive value is coming. That means there is a still scope for improvement in this problem. So again we'll do the same process. We'll select the maximum positive value here, which is 3, and this row, this column is called key column, and it defines that the variable x2 will now enter the basis, and again we'll calculate the value of theta and find out the leaving variable. Here theta is right hand side value divided by corresponding key column element. That means 380 divided by 3. 380 divided by 3. 380 by 3 divided by 3, that means this is 380 by 9. Okay, 380 by 3 and divided by 3. Okay, so 470 by 3 divided by 0 is infinity, and we will not calculate it, or put a dash sign instead. And the third is 430 divided by 5. So I'll double this, it will become 860. So this will be 86. And now we need to select the minimum positive value here. Okay, and the minimum positive, this will become 40, around 42. So this will be our minimum value, and this row is called pivot row. And now it is clear that the variable x2 will enter the basis and it will replace the variable s1. Okay, so I am writing here again. So now x2 will replace s1, and the remaining variables will be as it is. So coefficient of x2 is 3, and x3 is 6, and s3 is 0. Now again what we need to do here is we need to find our pivot element. So as in this column we can see the intersection of pivot row and key column is this. Okay, and we need to make this element as 1 and the remaining in this column as 0. So I will be dividing row 1 by 3, so that I'll be getting 1 here. So this will become minus 2 by 3 divided by 3 is minus 2 by 9. This is 1, 0 by 3 is 0, 1 by 3 is 1 by 3, 2 by 3 divided by 3 is minus 2 by 9, 0 divided by 3 is 0, 380 divided by 3 is 380 by 9. And for the second equation I can see here that I have already got a 0, so I will not make any change to this row, and I will write this as it is. This is 4 by 3, this is 0, this is 1, 0, 1 by 3, 0, and 470 by 3. And I need to make this as 0. What I'll do is, this is row 3 minus of 5 times of row 1. Okay, so this is row 3, older row 3 minus 5 times of new row 1, new row 1. So this will be 2 minus 5 times of this, that means 2 minus of 20 by 3. So it will come as minus 2 by it will come as 28 by 9. Okay, minus of minus will be plus, this will be 28 by 9. I need to make this as 0. So 2 minus of minus into minus plus 10 by 9, 9 to the 18, okay, 28 by 9, correct. And this will be 5 minus 5 times of this is 0. 0 minus 5 times of 0 is 0. 0 minus 5 times of 1 by 3 is minus 5 by 3. 0 minus of minus 5 times of that is 10 by 9, it is plus 10 by 9. Minus into minus will be plus, this will be 1 minus 5 times of 0 is 1. 430 minus 5 times of 380 by 9. So 430 minus 5 times of 380 by 9 will come as 1970 divided by 9. 1970 divided by 9. So 430 minus of 5 times of 380 by 9, this will come as 1970 by 9. So again I will be calculating the values of Cj minus Zj here. So I can see this 4 minus of this will be minus 6 by 9, or I should say minus 2 by 3. This is 24 by 3. Minus 2 by 3 plus 24, minus 2 plus 24, 22. Okay, this will come as minus 22 minus, okay, this will come as minus 10 by 3. This will come as minus 10 by 3. Okay, similarly this will be 3 minus of, so again I will be writing the value of x2, x3 and s3. That means x2 as 0, x3 as 0 and s3 is here as 0. As I know that the variables in the basis column will have Cj minus Zj values as 0. So I will not calculating this, I will be not calculating this, I will be writing this as 0. Now this will be 0 minus of this will be 3 by 3 minus 0. 3 by 3 is 1 and minus 1. Similarly here 0 minus of this is minus 2 by 3 plus 2 by 3 to the 6, and this will come as minus 4 by 3. And now by calculating the value of Z, I will be doing 3 multiplied by 380 by 9 plus 6 multiplied by 470 by 3 plus 0 multiplied by 970 by 9. So this will come as 3200 by 3. 3200 divided by 3. Now we can see that in the Cj minus Zj column, or I will say net evaluation row column, in the net evaluation row there is all the values are either 0 or negative. This shows that this problem has no scope of further improvement, and we will terminate our simplex algorithm here with Z max as 3200 by 3. So this will be our Z max, and this is the value of x2, that is 380 by 9. This is the value of x3, and this is the value of s3. Okay, so now what is different in this problem? So in the starting of the problem we have talked that the variable s1, s2 and s3, that is either slack variable or surplus variable, they need to be treated as we treat the decision variable. It means that the slack variable or surplus variable, any of them can take part in the final solution matrix. Here we can see that variable s3 is a part of final matrix and it is appearing in the final solution. Okay, so we can say that the surplus variable and slack variable both are part of problem and they need to be treated as we treat our decision variables. So this is clear. And one thing more we need to understand that if we have three variables, three decision variables x1, x2 and x3, it is not compulsory that all the three variables will appear in our final solution. Okay, here in this problem we can see that x2 has appeared with certain value, x3 has appeared with certain value, but x1 does not appear in our final solution. That means it is not mandatory that all the decision variables should appear in our final matrix. And so this is clear that s1, s2, s3, or I should say slack variable or surplus variable may appear in our final solution. It is clear to us. And we have also seen that it is not mandatory that x1, x2 and x3, all the decision variables given in the problem, will appear in our final solution. So in our final solution we can say that the value of x1 is coming as 0, the value of x2 is coming as 380 by 9, and the value of x3 is coming as 470 by 3. And by putting these values in the objective function, this equation, we will get the value as 3200 by 3. Okay, and whatever the value our slack variable takes, suppose in this problem the value of the s3 takes the value of 1970 by 9, and it does not affect our objective function, as we can see that we have already made the coefficient of s3 in objective function as 0. So s1, s2 or s3 will have 0 contribution to our objective function. So it does not matter what value s1, s2 or s3 takes. So this concludes our problem. For more such concepts about the simplex method and linear programming, please be with us. And if you like this lecture, please subscribe, and thank you and have a nice day.